Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Well, welcome to our Tips and Techniques series. This is episode 26, Sub-D Modeling Part 1. And in today's episode, we are going to do an exercise around an existing computer mouse. But first off, I'd like to just do a bit of background very briefly about what is Sub-D or subdivisional surface modeling. What are some of the pros and cons of Sub-D modeling? And what are some of the tools available to you to take advantage of to do Sub-D modeling? And then I'll talk a bit about how I plan to model this mouse in this exercise. And then we'll get right into starting to model the mouse, but using that to just introduce you a bit to the tools of Sub-D modeling. And then probably with part 2, we'll finish up with the model, explain a few more features of Sub-D modeling, and then finish out the two-parter on Sub-D modeling. So I've decided that I would like to use an existing mouse that is this Logitech MU007 wired mouse that I have a version of. And I picked it because first of all, it's asymmetrical for right-handed, and secondly, it's moderately challenging in creating a very continuous surface with some creased edges and other divots that would make it a challenging surface modeling exercise. And if you happen to catch my last episode, I had done this exact same mouse as a surface modeling exercise. So I did that purposely to show the contrast between surface modeling and subdivisional modeling. So if you haven't caught that episode, it might be worth you taking a look at that also after or before you watch this episode to just see the different approaches for both methods. So this is a visualized rendering of both the surface model and the subdivisional model mouse. I'm wondering if you can tell the difference between the two and which one is the surface model mouse and which is the subdivisional mouse. Well, if you guessed the one on the left, you were correct. And I think the giveaway is right around that crease that flows out of the left side control buttons. You can see a bit of difference there, and it's a bit more continuous. And but either one, either method can pretty faithfully produce the mouse. It's just that one is just a very completely different approach to modeling, and that's what I wanted to focus and emphasize today. So sub-D modeling, the background for sub-D or subdivisional surfacing, was invented by Catmull Clark in 1978. And by definition, it's generalized bicubic uniform B-spline knot insertion. That's a fancy way of saying that it generalizes patches, and then it subdivides on that. So you can tell from the graphic here where you start out with a 6-sided block, you just subdivide that in to 12 sides, and then so on and so on until you gain a finer resolution mesh that then you can locally start to edit. Another definition for it would be that it creates initial arbitrary meshes, and then its scheme is to make all those meshes continuous, or C2. And it can do that rather faithfully, except for where there's extraordinary vertices. And I pointed to one here with the blue arrow, and that would be any vertice that's shared by more than 4 faces, as it is here. Over the years, since 1978, there's been improvements on subdivisional modeling, and especially in the extraordinary points. T-splines is a good example of a significant effort to evolve and maybe even redefine subdivisional modeling. So before we had it in MCAD, though, it was primarily popularized through digital creation for digital animation, and primarily in organic shapes for the film industry, whether they be human or animal or sci-fi, whatever. It's a great solution for digital animators because it's very lightweight, and it also is very conducive for animation, that naturally is what you would do with these models in the film industry. So how does it differ from surface modeling? Well, it's actually almost a complete 180 from surface modeling. And what I mean by that is that it takes a radically different approach to modeling. It's a subtractive approach versus an additive approach. And what I mean by that, and it's kind of my best analogy, is that if you think about the manufacturing process of 3D printing versus CNC machining, one is an additive process, so it's adding material to create the form, whereas CNC machining is subtracting from existing material to create the form. And I think there's somewhat of an analogy there between that and comparing sub-D modeling and surface modeling. Basically, the workflow for a traditional surface model is in creating an organic shape, is to build up a number of network curves and then surface patches to then arrive at a final soft organic shape. Now, quite the opposite is true with sub-D modeling. Sub-D modeling starts with a very soft organic shape, and then you work to define it to harder and harder definition. So it's best used in product design when you have very organic shapes that you would imagine be difficult and take many, many features to do in surface modeling. Also, where there's ergonomics involved, like handles and areas where there's high human touch, it's conducive to those kind of forms and products. And it's also just like there's a point to where creating shapes like this just becomes so difficult to do and and requires so many features to do in surface modeling that subdivisional modeling is a very attractive alternative to that. So the pros and cons, this is really important that you understand that subdivisional modeling is not the answer for everything. In fact, it's rather weak in certain areas. It's very strong in other areas. So to just be brief about it, the advantages of it is that you can create very complex shapes with very few features, if not one feature. And with that shape, it has a high level of continuity. It's very smooth, and it'll stay smooth. That is important when you have products that are very organic, or they have a theme of flow to them that you really want to emphasize them to be smooth. The other advantage of it is that when you model in Sub-D, you're dynamically modeling. That is, you're pushing and pulling, and you're shaping as if you were had a lump of clay in front of you. You would be pulling and pushing and changing patches and surfaces of that Sub-D model as you visually get feedback of what the shape is. And so, as you can imagine, quite the opposite is sometimes true in SolidWorks, where you're in defining sketches and curves and you're building up to see a final result of a surface. Here it's that you're dynamically evolving and affecting the surface. The negative of Sub-D modeling is that it's not parametric or dimensionally driven for the most part. There are some exceptions, and I'll point them out in this series of how you can drive Sub-D modeling somewhat parametrically. But what's important to understand is when you go into, so depending on what Sub-D modeler you're using, they're mostly feature-based. That is, it's a super feature in the tree of a parametric history-based modeler. Once you go in and you define or redefine the Sub-D and leave that feature to update it into NURBS, which is compatible with the rest of the solid modeler, you can't go back and undo the work that you've done. You're basically, your session is done as far as undo. The other thing about it too is that, and this is a big one, is that subdivisional modeling is very weak or poor at defining very analytical and regular primitive shapes. So this is a tough one because a lot of product design is the combination of very organic and primitive shapes. So, and that's been traditionally that's been traditional for quite a while. So what I'm trying to say is that building a Sub-D modeler and having, let's say, one portion of it be spherical or cylindrical, it's hard to do that, to get it to a very defined primitive shape. So what usually is the best thing to do is to use a combination of Sub-D and surface modeling to achieve, or solid modeling to achieve your final form. And I'll show a bit more of that, and I'm actually using that approach with this exercise. The other thing too about it is that it can be really time consuming because you're basically modeling by eye. You're visually tweaking and moving and experimenting with the form, and your primary means of feedback is visual. It's fun because it's dynamic, but it's also tedious because you're making incremental moves and you're constantly tweaking on the form. And for some people like me, who I'm a perfectionist, you're going to spend a lot of time doing that. And you're going to see a lot of fast-forward videos of sub-D modeling because of that. So as far as what's available in the industry, the sub-D modeling has really matured into the MCAD space over the last 15 years or so. Just as a rundown, Fusion 360 with T-splines has been there for almost a decade now, and Siemens has just caught up with sub-D, introducing it into Solid Edge just this last version, and NX has a version of it too called Realize Shape. PTC, or Pro Engineer, or Creo, has had Freestyle for quite a while. I think maybe like 12 to 15 years. And Rhino is just introducing it. They've been in beta on this for a year or two, but now the version 7 is released that has sub-D modeling in it. And then, of course, Dassault Systems SolidWorks has 3D Sculptor, but it also has an add-in for SolidWorks called Power Surfacing that has existed for over a decade. I think it's worth mentioning that 3D Sculptor, which is the latest incarnation of Dassault Systems sub-D modeler, is not integrated into the core modeler. It sits in the 3D Experience platform, and it has a integration or collaboration path between SolidWorks desktop and the 3D Experience platform. Now, I mention that because I think that's a serious mistake on Dassault Systems' part. I understand and realize that with the 3D Experience platform, you're getting so much more, and it's in the cloud, and there's a lot of advantages to that. But the fatal flaw in that is that not having the sub-D modeler alongside in the tree with the solid and surface modeling features, it's going to make it very difficult to get your shapes done, because I've experienced that there's a lot of back and forth between the traditional modeling tools, surface modeling tools, and the sub-D feature or features. And I think that becomes apparent with what I'm going to show you, where I use some reference surfaces and some primary surfaces before I even start the sub-D surface. And I'm using those as kind of starter surfaces and also as helper surfaces. So that's where I have a hard time realizing how 3D Sculptor and moving between two programs back and forth is going to make an efficient workflow. And I could be proven wrong, and they probably have something in the works that's going to alleviate that issue. But for now, I'm going to want to be in SolidWorks desktop, the traditional SolidWorks, and with power surfacing I can do that because it sits as a feature within the feature tree of the SolidWorks that I know and use and take advantage of in a lot of the final product design. So I just mentioned about that hybrid between using SolidWorks features and sub-D features. And what I do in this computer mouse is I don't start with just a sub-D surface. What I do first is lay down some primary surfaces, namely the bottom of the mouse, which is it's the only flat surface in the product, but it's an important surface in the product because that defines the profile of the mouse as it touches the tabletop. Functionally, it's very important because it defines the space for the PCB or batteries and whatnot. That is a good starting point for any product like this. And what's good about it with SolidWorks and power surfacing is that any changes I make to that primary profile will be updated in the subdivisional feature. And then secondarily to that, I'm using some other features as part of the mouse. So underneath the mouse is a chamfered ruled surface that is much easier to define in SolidWorks than it is in the Sub-D model. And then in addition to that, I'm creating some helper surfaces. So that bounding surface on the back is to help the direction of the Sub-D surface, because I can use that surface, I can line to it, but I can also make tangent to it, the Sub-D surface, to help me get the right rake on the back of the mouse. So as I mentioned, in this episode, I'm going to be using the power surfacing add-in by InPower Software. And they were kind enough to loan me a seed of it so that I could do this. I've had a long association with them. I've really loved what they've done over the last years with their product, because they've added so many more features to it, as well as reverse engineering and the PowerShell and a lot of other things that are really helping product designers get their work done. So I really applaud them for that. And so at this point, I think I'm just going to jump into starting the base surfaces of the mouse, and then use just the beginning part of this episode as kind of a primer for how Sub-D works, how the tools and the handles and features work to create these kind of shapes. And then we'll get into the meat of creating the 3D mouse. So at the start of this exercise, I went and imported a number of high-resolution images of this mouse. You can see as I step through them here, I've even done just a trace with pencil sketch at the bottom of the mouse to get the defining edges of that profile. Put in some reference dimension and use sketch picture as a basis that is fairly accurate, actually, even over photographing. And then with that, I took a photo of it, put that in as a sketch picture, scaled it down to be in line with that pencil sketch. Did a top view, left side view, and in each one of these I'm obviously scaling it to match other construction of previous sketches to get all the dimensions correct. And then, so there's a left and right view on both the right plane. I just switch them on and off to see them individually. And then a front view, of course. Now, with the perspective of photographs, especially ones you get on the web, they're not, they are somewhat distorted. So you have to keep that in mind, that between photographs you're going to see discrepancies when you're using this method for reverse engineering. So just be mindful of that. If you take photos yourself of products, just make sure that you're at least like 10, 12 feet away, and then using telephoto with your phone or SLR camera would be the best method. Now I could have scanned the mouse because I do have a scanner, but I felt that for this exercise, having the mouse right here, if I needed critical dimensions, I can just take those dimensions with my calipers. And this would serve as a good basis for building up the design. Just refer to these. So let's hide those and then just move to the next part of this exercise, and that is to create some base geometry that is both reference and is actually used in this mouse. So probably the base feature would be the actual base, which is this profile. So if we roll back to that, we're just creating a planar surface that defines the bottom of the mouse and is created out of a single through point spline, or probably a style spline. And that becomes the basis for the entire design. From that point, though, there's some other surfaces that are just easier to create in SolidWorks than they would be as a sub-D model. And that would be this ruled surface that's this bottom chamfer. So it's fairly straightforward just to create a ruled surface, add a vector to the top plane, and then trim it back to its side profile, and then create some other reference surfaces. On the front of the mouse, there's also a somewhat ruled, it's not actually a ruled surface, but kind of a swept surface for the front. And I'm doing some basic surface modeling to get those surfaces. It would be probably a reference surface because I'll probably end up using the sub-D modeling with a hard edge at the front, but this is an important reference to do that. So just going forward here, from a side view, there's a very important curve here that we want to maintain that becomes the mid profile of the mouse. And then also there's some other curves that define where the creases of the mouse that flow from the front to the rear occur and then disappear towards the back edge. And so I'm creating those curves using two curve projection with these two features. And if you're not familiar with how to create those curves using projections, catch one of my earlier episodes on curves. So there's actually quite a bit of work before even getting to the sub-D, but it's going to pay off for you because these are all parametric, they can be moved, and they're a really important reference for building up your mouse. So adding a few more helper surfaces and curves to understand and define what's happening on the sides of the mouse. And then towards the back, with power surfacing, as is true with some of the other sub-D modelers, you can use surfaces to align the sub-D model to. You can not only align, but you can also make tangent. And so what I do here is I'll actually be using these surfaces to drive the direction of the hard creased edge of the sub-D at this point. And then I have another one in here. I'm not sure I actually ended up using it, but I did a fill surface on this back just to try to get a very continuous example of what that rear cap of the mouse is like. Because the design intent is that where your palm rests on the back of this mouse, it's almost spherical-like and very, very continuous. So those are the reference surfaces that become important. And I call it hybrid because we are using a hybrid approach of surface and solid modeling to get to the final goal. And it really speeds up the process because, as I say, there's certain things that sub-D is not very good at, and that is doing swept surfaces, organic planar surfaces, and just primitive shapes. And I'm using all these to my advantage to help that sub-D be successful. So let me go ahead and turn off a number of these reference surfaces because we're not going to need them immediately. I'll just hide them all, and we might want to use the base perimeter and the rear reference tangency, as well as maybe the front face. So with that, I can also just turn off, I'm probably going to use the right plane, but I'm going to turn off my front and top. And let's see, we can also hide these. So with that, we can get started to create our sub-D feature. And I have a tab here for power surfacing. I've set up my ribbon in the way and I like to work starting from the left with creation and then alignment and then modification and so on and so forth. And you can set this up however you want. Extremely important to have this because you're going to be bouncing back and forth between a lot of these tools. So we'll start with a box. 99% of the time I use a box. Sometimes I use a cylinder. And then the other thing to keep in mind is having some kind of quick access to your views, because you're going to be constantly changing views from the front view to side view to top view to manipulate the triad. So that's really important that you've got a quick way to do that, either here or on your right mouse button, however you want to set it up. And then one other thing I want to mention throughout this whole video is that there are going to be times I'll speed up the video, and it's really for your benefit so that you don't have to be labored through a lot of my tweaks. As I said in my intro, solid surface modeling, actually sub-D modeling, is a lot of tweaking, as is surface modeling, but even more so in sub-D modeling. So there'll be times I'll speed it up and then slow it down. And that way you don't have to be labored through all of my tweaks. So I usually like to visualize the mesh with the edges. And usually when I do a base feature, I'll just divide it by 2 in all 3 axes and put it on the midplane, which is a good idea. And then at that point, you're created your base feature, your base sub-D feature, and now you can go ahead and kind of move it around and tweak it. Now, a few things to explain as a primer about sub-D surfaces. Here you can see it. You have basically 3 ways of manipulating the sub-D. You can do it by vertices here, you can do it by edges, or you can do it by faces. And selection of all that is really important too. So for doing loops where you're going to be splitting faces, you want to double click in the middle of the edge and then create an additional loop here, or a number of loops if you so desire. So that's one thing with selection. Also, if you want to go the opposite direction, say I want the loop to be on top, you double click towards the outside of the edge. Let's do it here down on this loop, and you can get going that direction. Remember, outside of edge, middle of edge to loop the other way. And then as far as selection, I just do a lot of box selection. So if you select the whole thing, you're going to be moving it, the whole thing, and you'll be selecting through to the backside edges and vertices also. Another good thing to do rather early in the process is to make it transparent, because you're going to have references in here that you're going to want to see from your SolidWorks features, and making it transparent will make it visually apparent what you're trying to align to. So again, as a part of introduction, your work is going to be really focused on the triad. So the triad is much like the SolidWorks triad. There's a bit of difference here. So the inner arrows are translate. So I'm going to translate back and forth with everything selected. I'm going to translate in Y up and down with that one. The arrow right above it is scale. So if you pull on that, you'll scale it in that direction. If you want to scale it in 2 axes, you can click on the little square there, and now I'm just scaling it in those 2 axes. If you want to scale it in all 3, you pick on the center of the triad. And of course, you have rotation, and you have move XY in all 3 axes. So with that, just really important shortcuts to keep in mind as you're moving things around. You'll see why I use those tools now as I start to move this out to the shape that I want it to be. And at this point, it's probably a good idea. Let's move the bottom up. And at this point, we're going to just eliminate these bottom faces because we're going to align this whole sub-D with these surfaces I created in SolidWorks. So I've selected those, then I'm just going to say delete. And then on the front, it has a rather hard edge in the front of the mouse, so I'm going to select these four faces, and I'm just going to put a crease in those edges so that there's a hard crease. Let's reshape it a little bit, maybe divide it to get it closer to these edges that I'm going to eventually align it to. So we're going to just start working to move this around, and I'll probably speed the video up at this point just so you don't have to, wait for me to make decisions, and you can kind of see this a little quicker. Okay, so now that I've got the base of sub-D somewhat roughly aligned to where I'm going to align it to or constrain it to my imported geometry, there's a few other things I want to do. I'm going to, because this mouse has a crease like you can see here in this image, I'm going to actually crease those edges in my sub-D. So back here in the model, I'm going to grab these edges here and these edges here and right click and put a crease in those. And then once I have those creased, I'll just move these close to these vertices. You noted in the speeded up version of my tweaking, I'm moving between two different views of my model. And that's really important because remember, you're in 3D space, and where you think you are in a particular view, you really aren't. I'm pretty close here, but a lot of times you are not where you think you are because you're working in 3D. So my method is to work between two views, and here I working between the front view and then working with the side view. You can see how much I'm off in the side view here, as well as this one down here. So I'm going to move this into space and continue to do that, moving between my two views. So that's really important. So I think I've got it pretty close, and now we can move on to aligning it to our SolidWorks geometry. Okay, so we can move on, and now we have it in a rough form where we can start. Let's get this vertex in a little bit, and this one a little closer. And you can see how important, again, it is to work between two views, because where you think you are, you're not. So I see I've got, it's looking pretty good, pretty close. It's close enough. So now what we can do is we can go up here to this icon called Import Reference. And with Import Reference, we're going to import these surfaces into our Sub-D session. And I've got one, I've got one right here. And I've got one right here. And we'll explain that one a little bit later. And you can see now that with their import, they have their yellow isoparam shown, which indicates that they are referenceable geometry that we constrain to. So now we have the perimeter where the chamfer is, and let me just hide that one in front, that one surface, so we're not going to get confused between the two. So this upper part, I'm just going to click on this and say hide for the time being. And we're going to align the Sub-D edges to this SolidWorks geometry, and it will stay aligned. And also, if this SolidWorks geometry updates, the Sub-D will update on top of it. Let's get these vertices just a bit closer to these vertices of the SolidWorks surfaces. So if we move here, and you can see again how important it is to be able to use different views to see where you actually are versus where you think you are. So yeah, so I'm going to move this one down and in. Get it as close as I can, just so we're not, just so we make sure that it's gonna snap to that one. So with that, we can just say, if you have that selected, you can say to vertex, and it will snap to that vertex in the SolidWorks reference or imported reference. So let's just get a little closer, make sure we are where we think we are. You can see that I struggle with this also, even with using it as much as I have. So now that we've got it there, let's just do that again for that vertex. And once we have those vertexes, let's go ahead and do a loop select, but let's not select the back ones. We're going to align those to a different reference right here. So what I've just done is I've loop selected all these ones here, and I'm going to align it by edge to this imported reference. Okay. Now, this is an important thing. Why it is just been constrained. You want to go and make sure that the constraint is the proper one. And right now it's tangent to surface. I'm gonna remove that tangency, so I can do a hard edge and move these lines in without having tangency to the imported surfaces. I'm going to do quite the opposite with this back one. So if we just move this one, let's move this a little closer. And if we pick these two edges and say align to edge, on those, we're going to override the constraint to say tangent to surface, and it automatically did it right there. So that's just important to keep in mind how you're actually aligning, because now when I move these surfaces in right here, you'll see that it won't maintain tangency to that edge, and that's what I want. So there's one last imported reference I want to make constraint to, and that is on the front of this face. And so let's go ahead and turn that on again where I just turned it off. It's the front upper. And you don't really have to have it on. It's still going to see it. I just did that for visualization. So with this on, there's actually a good reason that I had it off, and I just forgot. Let's like I say, it doesn't have to be visually shown. Power surfacing will still reference it. But what I'm going to do now is say that I want these vertices, these upper ones, and let's pick this one and this one and this one. I want those vertices to be constrained to that face. Now I can do it that way, or I can just say I want these top edges to be constrained to that top edge. Let's try it this way. And I don't like that. So let's undo that. Maybe I can't undo that, so we're going to just remove that constraint. Yeah, and then let's just make sure that we've done that for all of them here. So I'll pick all these faces. And now let's try it the other way. Let's just say we want these edges to be constrained to the edge of the model. And I think that's probably the better way to go. You can see that it automatically made tangency. So again, you go to Constraints Override and you turn off tangency. So there we have everything that we need to be constrained, and we can move on in our model to start to reshape it to the way we want. One other thing I need to explain is we could have, when I made these edges hard, we could go and actually put a radius there by just softening the edge or putting less weighting into that edge. And if we want to turn that down, actually put a fillet in there, we can do that. The reason I didn't do that is if we just rebuild and just show it, that edge right there, which is part of the sub-D, will not show because the minimum radius of curvature is less than what you can show. So I generally, when I work in sub-D, I don't try to make radiuses or small radiuses in sub-D for that very reason. So I think that's just an important thing to point out if you're looking to really try to do that with your sub-D surfaces. So let's get back into the sub-D feature. And you can see that I lost my selection or my constraint here. Let's take these two edges. Let's first move this a little closer. And let's take these two edges, make a constraint to edge. And that one, excuse me, we do want to be tangent. So let's check that. It's tangent. And now it's going to be a process of just tweaking, doing a lot of tweaking. Oh, let's take this edge that we softened and let's go ahead and read to 100% again. And that's probably all I have time for in this particular episode. So we're going to go into a part 2 where we're going to finish up on this sub-D and then detail the mouse. And we'll wrap it up with that part 2 session.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project, or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.